What was the last contest? Division 2 round. E. As if state are the statements short for this? Short enough. Fence painting, sorting books. Oh yeah, I need to do one thing. In streams, this is not finished. If I'm late, then in Codeforces the stream disappears. Okay, now it is here. Alright, so difficulty will be around 1600 to 2000. Sorry for being late today. A few minutes. I will try to be more on time next time. Controversial Google interview problem. I will not do interview problems today. And the link is not up to date. So people are suggesting problem D, problem E from last contest. What about this? If difficulties are proper, let's do those two. What about that? AB graph and then sorting books. I think that sorting books might be too hard. What's the difficulty of this one, of sorting books? I will read AB graph. Hashcode practice problem? No, I did enough hashcode problems in my life. Complete directed graph with n vertices without self loops. Edges are type A or B. Edges are directed. Path of length m is a palindrome. Alright. Well, palindrome must be the same from the end and beginning, or the same when looking from the middle. So we need to investigate one of those two ideas. Let's see. And limits are very small, so it's not just like running DFS, because then n would be up to 100,000. By the way, is sound okay? My microphone is further away from me today. It's more convenient this way, but the quality of the sound might be a bit worse. You will also hear the clicking on keyboard better, which might be good, might be bad. Yeah, so what do we have? Is there... Oh, there is something here. One, three. So I think that the fact that it's AB doesn't matter too much. Oh. There are multiple vertices. If we go from the end and from the start, let's say that this is start, this is end, then we just need to follow the same type of edge. This is, let's say, A, and this is also A. Then we can be here in the second. So it seems that we will have a state of a pair of vertices, UV. And I know that going from the end, I can take a few characters, then be at UV. Then make a move from U, make a move from V. Like this, if this is the same type of edge. BB, then you can be in this new state. What do we need to print? Right, so, oh, I thought that m is the number of edges, but m is the length of a palindrome. There might be some cycles where we can get infinite palindrome. We need to reconstruct the path. Sound is very low, actually too low. Okay, so then I guess this is better. So not low at all, it is normal. No loops mentioned in the question. Remember that loops and cycle is a different thing. A loop is an edge from vertex to itself, while cycle is few vertices that form together a cycle. Okay, so the sound was fine. Let's keep testing this. This is the where when microphone is far away. If a lot of people tell me that there's something wrong with the sounds, then I will fix it then. Right, so I would say that on one hand you might do bool, some kind of, well, it's DP more or less, but possible. Whether you can get from the end to pair of vertices UV, but we want to have already, in the best scenario, we already traveled with a few edges. Again, going from the end. I imagine that we choose some starting and ending vertex, and we repeatedly travel through the same type of edge. So the last dimension should be the length traveled so far, or instead of bool here, let it be int, where it says what's the max length traveled so far. Like for those two vertices, this value will be 2, because I made 2 steps with each of them. So that's 4 in total already. And now if they are connected, their edges. Is this a full graph? Yes, it is a complete graph. I didn't notice it. Maybe that's important. Maybe it's always possible to do something. Like, if from every vertex there is an edge of both types, then we can always continue. Like, even if we forget about this fact that there are 2 types of, we go from the start and from the end. Oh, that changes a lot. I think that this is a key to solving the problem. If I start from just anywhere and I keep going, there is just keep going in any way. And now let's say I want palindrome of length 8. It means that now after ABBB I need BBBA. So I'm looking for anything of type B. Should I? Can I just go backwards? Is that allowed? Like that? So if M is even, can I just do this? Oh, UV different than VU. Okay, it's directed. I see. So those are directions. It's not that easy to come back. Right, but from this, if there's any out edge with type B, then I'm good. From every vertex, there's something of both types, A and B. So the only bad thing is if from this to all the vertices, there is only A. Maybe it means something smart. Should I maybe keep traveling between 2 vertices? What about this? if there are two vertices connected with A in both directions, then I can get infinite palindrome made out of them. Otherwise, if there are no two such vertices, it means that every opposite vertex is of different type. I can get infinitely long AB, AB, AB. So, sorry, you don't see it. So for odd M, I can just travel between two vertices always. If that's the same type, then it's only easier. Also, it would be better for me just to draw in a drawing program instead of like this. Right. So now, what if m is odd? I know how to do it. What about 2 dividing m, meaning m is even? Yeah, then I think the greedy from before will work, because if I have, let's say, A, B, and B, now I want BBA, but maybe everything from here is of type A. Okay, then that's still an issue. Oh, then I know what should we do. We should start from this guy, and then it's A, B, A, B, A, B, and at the end A. So if there is a guy, okay, let's summarize everything we know. If there are two vertices such that in both directions there is the same type of edge, like AA, then easy, because we just keep traveling between them. On the other hand, it's otherwise, from every vertex, if there is A outside, then there must be B inside for every directed edge. Fine. Now, if there is some vertex from which all the I cannot speak today, all the out edges are of the same type, like this, then that's also easy, because if you want to get, you just travel like this. AB, 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 AB. And if you want, so wait, that solves odd M. How was I supposed to solve even M? A, B, A, B, and then A. This is how I can get AB, AB, A. So that's odd M. What about even M? Did I know how to solve even M? And if there is no such vertex, then it means otherwise there is A and B from everything, so you can keep going starting from anywhere, and you will always find a proper letter. In particular, you can get string A, because you know that from every vertex there is edge of type A going out. For even you need 3 vertices. Alright, let's see. So this solves for this type the case of even, sorry, of odd. This is odd M. If there is this vertex, maybe indeed something is true if I look at 3 vertices. This is of type A, this is of type B, which means that the other way is B. One of those must be A. And what do I do with that? The other type, this is B. This is B. This is B. How to find here even length palindrome? where there is AA. Oh, there is AA and then BB. AA, AB, AB. Right, I think we need to start from here. If we go 1, 2, 3, 4, that's AB, AB. Then go there, that's BA, BA, BA. So first, from vertex, let's say that was vertex 1, that's vertex 2, that's vertex 3. This means that we first go 2, 3, 2, 3, 2 repeatedly, and then 2, 1, 2, 1, 2. Fine. So with non-difficult problems, it doesn't matter that much if somebody spoils something in the solution. It's not that I would spend otherwise, hours for a problem. Anyway, I'm surprised how difficult this turned out to be. Because n is that low, let's think if I can continue my DP idea, because this is a working solution. Okay, we got it. Just some cases. Basically, okay, first it was for any m. If there are two edges of same types in both directions, then just go through them. If from every vertex there are both types, then in particular you can get all A's. Okay, otherwise it means that there is at least one vertex from which there are only vertices of one type, say A. Then this is vertex 1 here. Just look at two edges coming out of it of the same type, A. Then go look at this edge between those two vertices, 2 and 3, to which I have edges of type A from 1. And depending on the direction between 2 and 3, we can figure out how to go AB, AB, and then the opposite, BA, BA. The key was to find apparently a vertex such that we go A in one direction but B in the other direction. Which means that it's enough to, I don't even care about this then. I just need to find any vertex with two types of edges, like here A and B, which means that this can be simplified a little bit. Let's always create path of L. So if there is a vertex, my logic will be first check this, otherwise if there is a vertex with out edge of type A and out edge of type B, so this is vertex 2, actually let's not call it 2, let's call it A, no, not bad name, V. To U1 and U2. Then I know that opposite type is B, so I can go V, U1, V, U1, V, and then V, U2, V, U2, V. That is, and if that such vertex V doesn't exist, it means that from every vertex there are only edges of one type. And that implies actually, I think, that all edges are of just one type. Yeah. Yes, we have just two types of edges, A and B, that was important. But I wanted to say, what about my first idea? So can we do something with int dp of uv, that's max length of path until a pair uv. Actually, this should be a pair or just some more complicated tuple if you want to retrieve, like reconstruct the answer, because you need to print the path. but that's n square states. And transitions aren't fast. N is 1000 or better? 1000, the sum of this 1000. We would need to consider only constant number of transitions. That's bad. Maybe it's enough to consider like one or around 2 or 3 edges from U and around 2 or 3 edges from V. But that's bad. Perfectly, you would want here complexity n to 4th power. For every UV, you iterate over the next vertex U prime. So from UV, you would go to U prime, V prime. But to iterate over those, that's extra n squared. So n fourth in total. Yeah, that was a bad idea. So we have this. Chat, do we implement or skip? And that was like, what, 1600 difficulty problem? I'd say it's more than that. Implement. All right, let's do implement it. Won't be like very time consuming. I'm running the virtual machine with Linux. But you should look at the construction in the editorial, much cleaner. Is it really that? Is mine not clean? I will look at the editorial after I get accepted. I still didn't fix the resolution issue. I just need to run this command at the start. Write down, those are some code. Okay, open. What's the problem title? AB graph. I will actually open the statement on my other screen, my other monitor. What do we have? Test cases, and I'm going to keep using this style of reading during streams. Actually, I'm thinking about switching to scene cout completely. Scanf is ugly. And M is the desired length that we want to achieve. For n equal to 2, there might be no answer, I think. Right, then we read the graph. Oh, this is just vector of strings. And now we can do something. What was the logic? First, for every pair from A to B, if both types are the same, you can keep moving between them. What do we print? Why not migrate to Ubuntu completely and use Windows in virtual machine? All right, why not the other way around? WSL, virtual machine can do more, and it's more full, I would say. Path itself as a sequence of n+1 integers. Okay, and the indices are from 1 to n, even though now I'm using from 0 to n-1 because of this. Right. Print yes, no, we are using cout. Print yes, and now n+1 times print if this is even, then A, otherwise B. Fine. Now, apparently, every direction is opposite. So from A to B and from B to A is different type. Fine. What are we looking for? Any vertex from which there are two types. Let's if all the types are the same, that's one thing, but otherwise, in particular, there will be something different than edge of A+1. If C is different than A and C is different than B, and then I found out that from A there are two different edges to B and C. Why did I take only the next after A? That's because if you have any sequence of, let's say, zeros and ones, if there are two different bits, then in particular you can look at any bit, including the first one, and you can say that there is different bit from this one. Otherwise, everything is equal to it. If there are two different elements, it's enough to compare with the first element to find any such pair. Right? And here I found the answer. If I didn't, I think this means that n is equal to 2. I wouldn't assert with this, I wouldn't submit with this during a contest because I only risk runtime error, but I think that this is true. Oh, printing A+1 and B+1. Thank you, Marksman. You're right. I need to print indices increased by 1 because I used from 0 to n-1. I even said it out loud. Alright. What do we have here? Just keep moving for some time from A to B, and then keep moving to the other one. Oh, that was for even M. And what about odd? Oh, I just keep moving to 1. So, oh, right, here. If length is even, then do this. And here assert that n is 2. Only then you didn't succeed. And for some time keep moving between those two. This is for sure even. Something's fishy here. Let's see. Length is, it says 6. What does it mean? Oh, doesn't this work only if the length is divisible by 4. Because I keep going AB. Yep. I didn't get it right. Sometimes it's good to implement even if you think you solved the problem. I didn't solve this problem. Q&A video and show your family and friends. What do you mean show my family and friends? That would be like, it's not zoo. No, I don't think so. Right, so this works off only if length is divisible by 4. How difficult is this problem? Right, let's say that I want to have A, B, B. Yeah, then there's nothing I can do. It's, That started from saying that I found a vertex from which there are two same types. Maybe that helps. So it's guaranteed that this is A and then B. All right, what do we have? A, B, A, A, B, A, maybe like that. Where? So I didn't use this. B, A, B, A. It seems that we're good. It's just that we need to start from this, not there. And we will need to start from here. So let's do what I wanted to do. So keep moving between those. And then at the beginning we'll insert one more occurrence of this, and at the end one more occurrence of that. I was going to go like that, but at the beginning of this. Okay, fine. It's good that it was possible to fix. So for a moment, assume that this is up to length over 4. So that many times. Starting from here, keep going. A and then B. Then same A with C. And additionally, if modulo 4 we are at 2, at the end we do this. One more time. No, A. This should be for divisibility, good divisibility enough. Okay, so now this completely is proper number of steps if len is divisible by 4. But otherwise, I need to add this at the end. And this at the beginning. Well, that could be easier. I will definitely look at the editorial. If length is the okay, this is for divisibility by 2. What is the case for non-divisibility by 2? I don't remember now. It's just going back and forth, right? All right. Go back and forth. A, B, A, B, A, B, A. I don't like how much time separately I'm printing yes. It's so easy to make a typo in that simple word. Just keep printing 0 and 1. We print len plus 1 times. And I need to add somewhere 1 to the index. Let's see, this is plus 1, AB, print +1. Okay, I'm saying it's like 50% that this works. Order, pushback, order, and this. Oh, nice. I didn't know that you can push back multiple elements. Maybe I will make a stream tomorrow after that Codeforces round. We'll see. Yes, 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 no. The lengths seem alright. Let's try. How quickly did people solve it? Alright, top people needed 15 minutes, so I don't feel embarrassed. It was a quite difficult problem. Okay, well, maybe division 2D should be that difficult. Will I now see the tags for this problem? I don't see the difficulty. Maybe the difficulty isn't assigned yet. I didn't participate in Quora programming contest. That's right. I opened problems at first seconds and I just looked at machine learning problems to see if I want to participate, and I decided not to participate. I will not say more because the contest is still ongoing. Tips for solving simple DP problems? Watch my DP videos. Whatever tips I have, I said in my lectures. Time limit extended on this problem? I mean, if you don't know a proper fast enough solution, read the editorial. Alright, so I will not do the next problem if it's much harder. Rather, the statement seems quite short, so let me check it out. And then after that, I will go through suggestions from the chat. Right now, I'm just reading this. If it's interesting, I will try. The N books with some colors shall look beautiful. One color should be next to each other. Take something and move to the right. So this is a very, very standard trick, is when you have a sequence and you keep taking element from somewhere and move to the end, then it's very important which elements you don't take ever. So it's like taking a subsequence and saying that it will stay as it is. And that's very, very, very helpful in this kind of problems. Say here. Is it possible that you will only move, let's say, this book to the end and this book to the end in some order? No, it's not possible, because this means that 1, 2, 3 will stay. And then in some way you will have 2 and 1, some order of 1 and 2. But that's bad, because 2's will not be neighbors and 1's will not be neighbors. The sequence that you're leaving must include some complete colors, and maybe the last one isn't finished. That's it. All by the last color, they must be already complete. So if there is a sequence, I'm maximizing elements that I will not touch, and I'm saying, let's say, those I maximize, so that I want to leave those untouched. This is good if they are some colors, where, let's say, this is 4, 4, 1, 1, 1, and those 4 remaining elements I move to the right. This is good if there are no other 3's or 4's. If there is some 1 here, it's okay, because I'm moving this to the right, so I can put it just after 1's. but if there is any free here, I will not make it neighboring with those. Right. So yeah, always when looking at the sequence from the input, if you don't know what the numbers are here, what will happen? This is some kind of DP for sure. You can look at, let's say that first you take some group of equal colors, and that must be a complete group. So the important fact is that you will finish somewhere, and then you will keep taking from this suffix. And how many things of this color were here? So always, I think always when looking at some index, let's know if this is the last occurrence of element of this color, if there is nothing more of this color on the right, then look where the first occurrence, this J, of this color was. Let's consider something more interesting, where this is the first occurrence of the same color, J. Because maybe, for example, this was 4, 4, and 4, and those are the only 4s in the whole sequence. Then I say something like dp of I is maximum of itself, comma, dp of j minus 1 plus 3. dp of I is how many elements I can leave untouched until here, taking just full groups of some color. For every I, if this is last occurrence, so if I is last occurrence of this color, then dp of I is maximum of itself, or just like that, where dp of j minus 1 was the best split up to here. And also, if I know how many elements I can take up to the previous position, then this is allowed. Of course, doesn't matter for the first element. I think that's the solution. And well, okay, and J is first occurrence of A of I. While plus 3 in recurrence, 3 was just the number of elements here. So this is not 3, this is count occurrences. Yep. Then at the end here I will know how many colors I can take, but that's not everything. In this suffix I can take some incomplete color. So always when I'm looking at I want to say, I want to maximize answer with what? dp of I, how many full groups I could take on the left, plus in this suffix, just take anything of the same color, but it's allowed if I take those 5s, and there is some 5 here or here, because I will move those 5s to the end. It's okay to leave those 5s untouched and move everything not taken. So max occurrences of same color in suffix of I plus 1 to, from I plus 1 to n minus 1. Those 3 arrays are trivial to compute in linear time. This one is just a little bit more difficult, but still very possible. Can we just delete the number of elements other than the elements occurring in longest subsequence? What is longest subsequence? Longest subsequence is the full sequence. Longest increasing subsequence, do you mean? Or what? And at the end we print n minus answer, because answer here was the number of untouched elements. So we maximize the number of untouched elements to say that we minimize the number of moved elements. Ericto. That's an interesting nickname. How to improve recursion skills. Practice recursion. Will you try to send it? No, those arrays are boring thing to implement. So, not really. You should remember this. When you move stuff to the end, or also at the beginning of the sequence, and you minimize the number of moves, actually focus on elements that do not change their position. Almost always that's what you should focus on. Longest subsequence of clumped unique elements? One having same colors? Well, but it isn't true that you will just leave sequence with one color, subsequence with one color. The example is this. Consider the sequence 1, 1, 7, 8, 1, 2, 5, 2, 8, 8. Here, actually, you should leave 1s, 2s, and those 2 8s. It's enough to move 8 and 5 to the end. Let's first move 8. Everyone wants to know this one. Can you give please a short explanation to the problem I'm solving? I think I gave an explanation. The same idea. Oh, I just know that there are problems like this, but I don't know a particular title. It's not that I will remember this one, but it's a nice problem, though a little bit standard. I will scroll chat a little bit up to see what were the earlier suggestions. Division 1C, this is not a so boring one. So, Osmosian, what's the difficulty? Division 1C seems to be too difficult, I would say. Well, maybe not really. So this is some problem. Apparently I solved it a long time ago. The Millennium Prize problems. I prefer to solve problems from Codeforces, then I know what to expect from difficulty-wise. Oh yeah, I was supposed to check out the editorial for the previous problem. Somebody put their submission here in the chat. Well, that's harder than my solution. But let's see. For the previous problem, so this one, what's the tutorial solution? It isn't easier. They also have ifs for length modulo 4, 2. Yeah, same value between x and y. If m is odd, then do this. If m is even, right, that's not easier than my solution. Read the editorial but couldn't understand it. Nearest opposite parity. The statement is short, so that's a valid suggestion. Please also tell me the difficulty of those. Red-green towers, suggested for like the third time. That's an old problem. I prefer something more recent. What is my English level? It is what you hear. You teach amazingly. Thank you. Thank you, Yuvray. Check this. I mean, is it that much shorter? Okay, it is shorter than my solution. this we check the visibility by 2. If this go to hell, where is hell? Here. Oh, I think the main trick is that thanks to having 3 vertices and saving them in some smart way, we can print always in one code, and that helps a lot. I guess we just move between X, Y, and Z. This is, I would say, smart overall look at the solution. It uses goat. That's fine. You could say that you could make this into a function that returns 3 values and just runs return. Goto isn't that bad. Tabs as 8 space, not 8. Okay, how do I change that? In Codeforces, how to change tab to 4 spaces? Okay, what is this? Recent problem, the difficulty seems proper. Jump from I to I minus AI, or this. So if somewhere there is element 4, it means that you can jump by 4 in either direction. And what do we want to achieve? From each position, note the mean number of moves required to reach any position j such that a j has different parity from AI. Right? Let's try that. Just like with the previous problem, not necessarily I will implement. Wait, did I close it? What happened? Oh, I guess that I opened it in different system. I think. Maybe not. Okay, I lost it. How did it happen? Where is my problem? Okay, it's this. You don't need to, you know, type all the tags because that's too big of a spoiler. Also, of course, I cannot check out all the suggestions. Sorry about that. Right now I'm solving something, so no more suggestions. Jump by AI, and you need to find something with different parity. Well, that sounds like Dijkstra? More like BFS. Just reverse kind of BFS. Right. Well, if you have a sequence, there is a 3 here, and then you have 2 choices where to go. Go by 3 to the left, or go by 3 to the right. If any of those is even number, like here there's 6 or 4, then you are already done and you say that the answer for this guy is just a single jump. You went to something with bigger parity. And now, if both are if both are odd, then you're interested what's your answer. If I know that the answer for this guy is 6 jumps, and for this one it's just 3 jumps. In 3 jumps he can get from this odd parity to something even. Then I say that for this one there are 4 jumps required. That's minimum of those 2 numbers plus 1. But I don't know the order in which I should compute values. So I should compute the answer for this one apparently faster. It will be kind of like reverse BFS. When I print distance 3 here, the 3 jumps, I go through inverse neighbors kind of. I need to find quickly all the cells from which I can jump here in one move, and I tell them, hey, your possible distance is 4. So the fact that there is edge from like that, from this I create this kind of edge and I run BFS. All right, and also if I see an even number like 20 and there was an edge like that from something odd like 15, then I have this reverse edge, and I say, actually I can do that with normal edges, not reverse ones. Just initialize the distances 1 as start of BFS. This will be more multi-source BFS. So for this guy, I know that in one jump I can reach the destination, something of different parity, and then use those reverse edges to run BFS, multi-source BFS. Implementation will be very short, so let's code it. I've solved 30 questions on Codeforces and my color isn't changing. Well, you know, it would be very nice if solving 30 problems was enough to change our color. How many colors there are? 10? I don't know, even fewer than that, but let's say 10 times 30, 300 problems to get LGM, to get the highest color. That would be so nice. This is like, what, let's say 2 problems per year. That's 5 months. Imagine that everybody in 5 months can reach Legendary Grandmaster. I think something would be not right with that system. I solved around 3,000 problems, and I don't think that my color changed 10 times. Or like, I'm sorry, it should change 100 times. So yeah, you can look at my graph. For 3 years, I had roughly the same rating. If you have if you roughly have the same rating for like 6 years, yeah, then you should worry. Right. Let's create parity problem. I'm implementing this mainly because the implementation won't be difficult and will show well what is going on. Let's call it jump instead of A. Or okay, A is fine. Read. I keep using scanf when I don't think about it. And it will be hard to switch to scene. And now. For jump for new index j, either I minus AI or I plus AI, if you are in the bounds, then first, if parity is different, then say that the answer for I is 1, but we'll do something more. Initially fill all the answers as -1. That's what we print when it's impossible to reach this. For this guy, the answer is 1. Actually, we can already run this to check if I'm reading and iterating properly. Why didn't I print anything? Well, because I'm not printing the answer, of course. How many questions in Codeforces? I don't know, 5,000? Mm, 67 pages times, I would guess 100 per page. That would be 6,000. The number of contests is around 700 times around 6-7 problems per contest. Yeah, plus there is Dream as well. Combined rounds have at least 7 problems, sometimes 8. But 6 times 700 is at least what they have. should be around 5000, this magnitude. Yeah, did I print it? 1 1 1. All the ones should be alright. 1 1 1 1. Good. Now use reverse edges for the reverse edges from J pushback I. And start BFS from all the ones. Q pushback I. This is Q for BFS. Start from all the positions with ones. I think something is missing there. For every index in this Q, this guy is, let's say, I. For every edge, reversed edge from I. So this actually means that the actual edge is from J to I. So if I know answer for I, then I can update answer for J. If answer of J is still infinity, but maybe I should check the parity. When should I use this edge? Well, oh yeah, I had this logic with 3 jumps, 6 jumps. Well, that assumes that both of them, they have the same parity as me, but if that's not the case, then the answer for me is 1, so I will not mess up my answer. So I think I don't need to do anything more. Alright, this seems good. I will maybe make a drawing to analyze what happens for this test. Accepted. Cool. Let's take this test. What do we have? Actually, why should I rewrite this? Let's make it bigger. Not a beautiful font, but I wouldn't type it better. So for every element, consider what happens if you indeed jump here by 7, 2, 4, 6, 7. Okay, it's different parity. 7 and 4 are different parity, so I immediately say that the answer here is 1. And apparently, same is true for those. Oh, I did something wrong. 1, 1, 1, 1. Let's check this guy. If you jump to the right by 4, that doesn't work. To the left, yeah, indeed, different parity. Now, I know answers for them, and there are a bunch of other unused edges. In particular, there is, from this guy, there is edge of length 6, 2, 4, 6 to this one. So I save the opposite edge. I save this. There are a bunch of other edges, like, let's say from this one there is standard edge here, so I save this. From this one there is an edge here, so I have this reversed edge. Every such yellow edge, the reversed edge, it just means that in the problem from here I can jump from there. But from me, this is information that if this guy has answer 10, then this guy has answer 11 or better. And there are a lot of other edges. But now I take all the vertices with 1, and those are starting vertices for my BFS, and I update along with yellow edges. So I have 1 here, and there is edge 2 there, so I put 2 there. I see 1 here, and there is an edge there, so I put 2 here. Nope. In BFS, you only minimize the distance. There was 1 already here, so you don't override. There is this edge from 2 to 3, put 3 here. LeetCode good starting point to get into algos? Not really. LeetCode is good only if you want to do coding interviews, not algorithms in general. If you like math, then you should get Corman's Introduction to Algorithms. If you don't like math, then some more casual book about algorithms. Tutorial on monoQs? Yes, I need to do it, but not this month. No, I'm not taking part in Quora programming challenge because I don't like machine learning problems. Not like it means I'm not good at them. How to set up a compiler like yours? I think I did videos on setting up Linux and Genie. Fine. Something else? Again, I'm going to scroll up a little bit to check some old suggestions. There was beautiful array by Edithia. Short statement, so let's check it out. Given an array with an integers, BOT maximum sum of some consecutive subarray, choose at most one consecutive subarray, and multiply all values by x. Fine. Good problem. We're doing this. And I prefer to keep in range from 1600 to 2000, let's say, the Codeforces difficulty. Please speak English only. If we are to find max subarray without any modifications to a subsequence, that's cadence algorithm. No, this thing. And either that, which is I think not very intuitive algorithm, and it's much easier to just come up with solution yourself, or you can do something DP style, basically the dynamic programming, where you just keep going and your DP state is either that you didn't take anything yet or that you started taking and you need to take every next element. Or you can use prefix sums. So multiple possibilities of what to do to solve the standard problem, and we want one of them to work with this modification. If a problem is some variation of a well-known algorithm, then you need to know how to do the well-known algorithm, and sometimes only one way to do it will be possible to apply it here. Maybe there are 3 methods and you need all 3 of them, like to check them one by one, because one of them will work. Oh, whoa, that's interesting. Today in Twitch you can choose between qualities like 720p. It's not that I did it. Always you can on YouTube downgrade. I don't need to pay for it. Actually, I should just grab Twitch affiliate and then they would pay me. But then I couldn't stream to YouTube at the same time. How much to practice? As much as you want. The more you do, the better you will be. So I immediately know that the DP solution can be applied here. Right, let's see. Is it true that we will multiply, if x is positive, then my guess is that we will just multiply the whole subarray that we take. Does it make sense for this sequence to multiply some big subarray by x and then take only some part of it? No, that's bad, because then why did you touch those elements? But maybe some small part, this we will multiply, let's say we multiply by 5, this times 5, and then we take this whole part. And this is optimal subarray to take the sum of. That's stupid as well, because if you want to take those two elements, apparently their sum is positive. Otherwise, why would you take it? Like if they are negative, or let's say this is 1 and this is -5, then it's better not to take this extra plus -4. If you take this part as well in your optimal subarray, it means that this is positive, so it's better to include it as well in the multiplication. Same reasoning for the other hand. So I claim that for positive x, we would just multiply the whole subarray by 5. So we can as well just find max subarray and multiply that answer by 5. That's if x is positive. For 0 or negative, that's a different story, because x equal to 0 can be useful for cancelling some negative elements in the middle. And then I believe, again, imagine that this is some sequence. On purpose, I'm not putting values there. This is just a concept where I can think, oh, what if I take this interval? If this is optimal subarray to take, then does it make sense to turn into zeros everything here? Let's say from here to there. Well, again, if I'm not taking this prefix, then what's the point in changing it? Maybe this prefix I should change to zeros? Nope, because then what's the point in taking them in the subarray? If I change this to 0, then I shouldn't take it. It's better to just take those 3 elements. Right? This can be sub-interval though. If those are negative elements, it makes a lot of sense to turn it into 0, and then I will kind of get some of those values and some of these values. So with x equal to 0, I am basically allowed to take 2 intervals, 2 disjoint intervals. Yeah. And for x smaller than 0, this makes even more sense, because negative elements in the middle I can turn into positive. So for x equal to 0, this case turns into take interval, then some values multiplied by x being negative value. So this changes all negative values into positive values. And then take this suffix, some kind of extra interval with plus multiplier. You might say, maybe then you might get this lemma, which is incorrect. Maybe we should multiply only negative values by this x. Not true. Counterexample is this: 10, 10, minus 9, 1, minus 9, 10, 10. And x is equal to minus 3. It's optimal, I believe, to multiply this whole interval by minus 3 and then take everything. This 1 is positive, but it's very small, it doesn't matter that much. So it's better to take it as well, to turn it into minus 3, sadly. But then we have 27 and 27 instead of negative values, and we can take like a lot of 10s, a lot of 27s. That sounds better. Yeah, what Osmosian said like a minute or two ago is a correct solution. But let's get to that. Generally, because of how complicated the structure of this is, so we take some interval, then something multiplied by negative value, then something again, I wouldn't say that something as easy as Cadane's algorithm will work anymore. We cannot do stuff greedily, kind of. Though Cadane's algorithm is actually more or less DP. But there is a general solution for a problem like this. You're given a sequence and a bunch of multipliers. Let's say that multipliers you can apply are +2, -5, +3, +7, -1, and +6. Those are multipliers. And you need to take some interval here, split into smaller intervals, such that some part you multiply by times 2. Let's say this is times 2. Then next part, just after that, you multiply by the next multiplier, and so on, times minus 3, and so on, and so on. Imagine that this is, of course, a longer sequence to really use all those multipliers. You can solve this problem in complexity length of the sequence times the number of multipliers. In our problem, m is equal to 3, because the multipliers that we use are 1, x, and 1. We have just elements, then something we modify, times x, then again just elements without modifying them. It's allowed if some of those parts are empty. It's not that we need to take some elements not multiplied by x. And how to do it like that? That's dp. In dp, we almost always go through a sequence from the left, and we decide something about every next element. We decide the fate of this element, we decide the fate of this element, and so on. When we look at some element, or maybe it's a bit easier to say that we are between elements. So let's say we decided about all of those. We either didn't take them or we assigned some multipliers, maybe starting from some suffix of that. Maybe this got multiplier 2, minus 5, minus 5, so on. What is important so far? The question from my DP lectures. The current position, to know like what will be the next element to take. The sum so far, the answer, that best answer, and last used multiplier. I need this last thing because I cannot use a previous multiplier. If we go with this array of multipliers, if I used minus 3 for this guy, I cannot use multiplier 2 for this one. I need to just use the same one or the next one. Of course, sum so far is something huge that we maximize, so this will go outside of state. We'll have dp of I, last used multiplier, where int denotes the max sum so far. And always from dp of, when we look at the ith element, we will decide about its multiplier, and it must be something not earlier than this one. This actually will be index of last used multiplier in this sequence. So I think that this will be the last problem for the stream. So it's implement actually not this problem, but actually something more general. Let's say that we're given such a sequence of multipliers. When did you practice most problems? Beginner, intermediate, or pro? I don't know. I guess intermediate and pro. How did the PS you apply today come into existence? I have no idea. I don't study history of algorithms. Dynamic programming was for sure used for past tens of years. I know something about the history of name dynamic programming, that it was supposed to sound nice, so they would get funding from government. All right, let's create a function, max sum with multipliers, where we are given an array and a sequence of multipliers. M will be the number of multipliers. We will create something like this, but this is to fix plus minus 1. Hate C++ syntax? That's understandable. I don't think that it's the best possible syntax. We will start by saying, oh, I think what's also useful is to say this. At the beginning of multi, let's insert 0, and at the end, at multi.end, insert 0. So now instead of multipliers like 2 minus 5, 1, we want to change it to 0, 2 minus 5, 1, which makes more sense because prefix of the array and suffix we just take with multiplier 0, which means we don't take them. Now I will take every element, just possibly with multiplier 0. Okay, this state is possible, and I will say that its value is 0. Normally every other state is marked as infinity for every ij, but I think that this is not necessary if 0 is at the beginning. This anyway, if I don't do this and by default I fill everything as 0, then that's fine. It's just like saying that I can skip this prefix of values and this prefix of multipliers, and I can get some 0 from this, just because of that. But yeah, so not a very important thing. For every element, let's say, and for every last used multiplier, when we already know dp of ij, I want to now decide about ith element. So either I can use this current multiplier, and then from dp of ij I will go to this new state. This will be I plus 1j, maximize with itself, because I maximize, yeah, I maximize dp of ij plus a of I multiplied by multi of j. And here I can type dp of I plus 1j, but let's create a helper function maxi. Also, dp sounds like long run. This is function that, if first number is smaller than second, then it assigns them. Very useful in dp, because you don't need to repeat a term. Cadence is indeed linear time algorithm. Why did I say that it's not? Will I upload this lecture? All the streams are available on this second YouTube channel, Aricto2 on YouTube. Alright, like this. Well, those are int, so if they can be long log in total, don't need to cast. Also, it's okay to use some different multiplier, some later multiplier, and I could be stupid about it and do this, just iterate over a multiplier to use. Let's say like this, and now use the kth multiplier and say that the new state is element I plus 1 with multiplier index k. But this is cubic now, n times m times m. It doesn't matter with this beautiful array problem because m is free. The number of multipliers is free. 5 if we add zeros, whatever. But instead, it's better to just consider using this multiplier or skipping this multiplier. This means that I decided not to use multiplier j. I mean, at least at this element, I. And maybe from j plus 1 I will skip it as well. You can imagine this as two-dimensional grid where you have a sequence a0, a1, a2, a3. Then there are multipliers m0, m1, m2, 3, and so on. Kind of like with LCS. And in every cell of this grid, this is dp of 0, 0, for example. You can go to the right or you can go down, and sometimes it has some cost. This is a possible interpretation. Not really useful, but if you spend some time thinking about it, maybe it will make the problem more understandable for you. So yeah, this is long, or actually, to make it nice, what's going on? I cannot type int. Okay. Actually, you should use vectors in C++. Filled with infinity. n by m. I don't really like using that huge infinity because then you keep overflowing. I prefer to use something like 10 to 18, that should be enough. In Python, when you have infinity, if you add it to anything, you will still have infinity. In C++, that overflows and gives you something negative. So it's dangerous to use long log max. You cannot add it to anything. Right. So this state is available. At the end, what do we print? What do we return? For sure, we already decided about n minus first element, so we moved to dp of n and something. And here, it seems that m minus 1 is good enough, because it means that the last used multiplier was the last one. It's fine. So here from 0 to n, and let's say that last used multiplier will be from 0 to m minus 1. So then j is not minus 1. Only then I'm allowed to skip a multiplier. Otherwise, I need to finish with those zeros. I think we're done. What if we remove restriction that we can select any numbers? Then any number you can, if you add this single line, so it's like the next line, just we don't add it. It means skip an element completely. It would mean that we don't take consecutive interval, consecutive sequence of values. It means that we can take any single value, just in this order. Some of them on the left we multiply by 2, then some of them in the middle we multiply minus 5, in this case, of course, and then by 1. All right. I think that's it. Oh, why am I typing in problem parity? Shouldn't be here. That was problem beautiful array. Let's call it dp multipliers. That's the function. That was the thinking part. And what happens in main? Let's use sin. Read the array. And print max sum given an array and multipliers 1 x and 1. But this solution is much more general. I forgot the bracket. Well, we printed some infinities. That's not good. Maybe because I maximize, so infinity seems to be the best state. So if I maximize, then I should initialize as minus infinity, as impossible state. 15, 35, and 0. That's not correct. 49, was that? Oh yeah, I shouldn't skip elements. Thank you, Imla, for saving me some time. 14, 35, still bad. My answers are too small, so I'm not allowing something maybe. 14 here, what's the 14 here? That's 8, and then I would multiply this by minus 2. That's minus 8, minus 7, 14. 14 plus 8 is good indeed, right? Well, there are two methods to debug this. First, let's try to read code. Maybe I will notice a mistake. Second, I can print some dp values. So even if you see a mistake, for now, don't say it. I will show you how I would approach the debugging part. Right, n. I insert 0 at the beginning and at the end, so I should get 0, 1, x, 1, 0. Those multipliers. There can be empty, Sure, they can. dp from 0 to n and from 0 to m minus 1. Start as 0, then we first decide about element I equal to 0. And either we skip this multiplier and we move to the next multiplier, but good, we still look at this element I, or we move to the next element, still allowing the same multiplier to be used, and we increase the answer by ith element multiplied by this multiplier. Seems good to me. So let's print. What do I want to print? Here. Right. After, so when I look at the 0th element, dp of I0, this is not really readable, is it? Let's change it a little bit. All right. When I look at 0th element, no matter what multiplier I'm allowing now, that's 0. Then, when I'm looking at the first element, well, I possibly took the 0th element with multiplier 0, so I skipped it. If I'm looking at multiplier at least 2, so that's 0, 1, x. If I used minus 2 the last time, I possibly got 6. That's good. Minus 2 times minus 3, that's 6. Then 2, 0. So and when I'm looking at 2, possible dp should be 8. It is 8. But then it keeps decreasing. Strange. I want dp of this after I'm done with this. So dp of 3, let's write it down. dp of 3, because I'm done already with the index 2. And now multiplier, the multipliers are 0, 1, x, 1, 0. So by using this multiplier, I should be able to turn minus 2 into plus 4. That's plus 4, so 12. I think that this should be 3, oh, this is 12. How did I get 14 that early? Oh, that's like multiplying this by minus 2 and this by 1. But still it's possible, thanks to this, to take just 1, 8. So I don't waste minus 2 on this guy. All right. So 3, 2 is 12, and that's something towards optimal solution. Then with this 1, I still should be allowed to multiply it by minus 2. Debug is just like CRR. Just better. Just it can do more. Can print, for example, variable names. It's some template that is here at the top. Very complicated template. Right. 3, 2 is 12. Then we look at 1. Possibly I will be at dp of 4 to as 10. dp of 4 to is 10 indeed. And then I use it. Oh, I see. When I use this multiplier, I will move to dp of 5 to, because I use this multiplier. So this, let's remember, it denotes the last used multiplier, possibly increased to the next one. But after with I equal to n minus 1, when I use it, I here move directly to I plus 1, so dp of n something, and I don't change this j. So I think that I should instead take minimum among the last used multiplier. You see, I just understood my DP, where I knew what some cells should be and how I should derive this 22, because I know what's the look of optimal solution here. I take this with multiplier 1 and then all of that with minus 2. I got this, that's bad. Oh yeah, minus infinity is neutral element to maximize then with some other elements. 42 and 0, good. Let's submit. Complexity is n multiplied by constant time, multiplied by 5. I don't need to remove this debug thing because it only runs locally. Cool, accepted. The time, my running time shouldn't be very good because I just have so much unnecessary stuff. Like, it's not that you always should implement things in such a general way. No, during a contest you just want to get accepted as quickly as possible and write an efficient code. This needs to be a standalone lecture, seems so generic and useful. And DP is such a broad topic. You can make tens of lectures, and this is just one quite standard problem that you should know. But you know, if you think that the streams are useful as standalone lectures, then just watch the streams. I'm happy about how they look like recently. Yeah, I'm not accepting new suggestions. This is it for today, especially because still Petrozavodsk is going on. So even today I spent in the morning 5 hours on solving problems in the contest. And possibly tomorrow I will do post-contest discussion on this Codeforces around 700. Maybe only on Division 2 problems if I only solve those. I will decide about it today, and if I decide to stream, you will see my stream scheduled here in Codeforces. I'm happy you all liked the stream. See you next time tomorrow or maybe next week. And also next week, some days I will not be in Warsaw, but in my family town, so then I might skip a stream or two. Check out the Discord and calendar. Accent has improved a lot. Thank you. I guess it's just about practicing English. I still am going to get English lessons. Tab width thing. Okay. Well, I read my messages eventually. Hey, I just joined. Is this not the second time where somebody is joining like the last second? I don't remember if it was the same person. Right, because I don't see streams here, I will not rate anybody unless Xiaouk is now streaming. I don't know if now it's this time. No. So, no rate. Bye-bye. And thank you for Happy Sunday. You too.